Hi viewer, this is EasyElimu channel. I'm Vincent Kanumaya and I will be taking you through Form 3 Mathematics, Sequence and Series. Stay tuned as I welcome you all. We are going to observe certain numbers which are given in form of pattern such as 2, 4, 8, 2, 4, 6, 8. Then they may be in certain pattern that they follow each other. We have another one like 1, 4, 9, 16. Another one may be like 1, negative 2, let's say negative 4, actually 4, not negative 4, 4, negative 8, and so on. From these numbers, we can obtain other given numbers because we can predict the pattern and its behavior as it moves on. For the first one, as you can see, the number is from 2, 4, 6, 8, and you can see that if you want to find 4 from 2, it's like you are adding 2 to the first number so as to get the preceding, to get the successive number. So the same applies to 6. If you want to get 6, you will have to add 2 to the preceding number so as to get that successive number. The same applies. So meaning that in order to get another number for this pattern here, you have to be adding 2, 2, 2. So meaning if you want another number here, we are going to add 2 and you will get another number will be 10. And if you need another one, meaning you can predict some more as they go on, you will add 2 to get 12. As you move on, you will be adding 2 and find out you will get another number here like 14. As you move on, there will be a pattern like addition of 2. And here, you will find out that you are going to find this one here is 1. Here is 4, here is 9, and here is 16. As we can view there, you will find out that to predict another number is still easy in that, as you can see here, this number here has been squared. If you square 1, you will find 1. And here is 1 which was squared to obtain that 1. Here it is 2 squared. As you move, 3 squared, 4 squared. Meaning the next one will be 5 squared, another one 6 squared, 7 squared, as you move on. So meaning the prediction of the numbers is still possible. Here we shall find 25, 36, and also 49 as we move on that way, 64 and so on. And here, as you can see, we are having 1, negative 2, 4, negative 8. To find the next number, you can see here is still easy in that from 1 to negative 2, you will find out that this one being a number has been multiplied by negative 2 to obtain negative 2. And for 4, you will find out that this negative 2 here has been multiplied by negative 2 to obtain positive 4. The same apply here. You will find 4 has been multiplied by negative 2 to obtain negative 8. So meaning there is a pattern in which these numbers are obtained. For example, if you want another one here, you will take negative 8 multiplied by negative 2 and you will get here, you are going to get another next number as 16 as you move. So it will be negative, positive, that way as you move on. So meaning here, to find another pattern, you are going to multiply by negative 2. Here you are finding the squares of the numbers as they proceed from 1 onwards. Here we found we were adding 2. So we can say now that if you find some patterns of number arranged following due to a specific rule, then we refer to that pattern as sequence. For here, this is our sequence in which we have to add 2 in order to find the successive number to what we have. And here is a pattern in which next number to find, you have to square the numbers like 1, 2, 3 as you move on. Here we multiply by -2. So any pattern of numbers arranged with a specific rule, we do call that as sequence. Now we shall observe another one. From before we observe, we shall say that as you may see here, every pattern here has a starting number. Every pattern has a starting number. For the first pattern, the starting number is 2. Here we have 1, and here is also 1. So we shall consider this first pattern. And for the first pattern, we have 2. 2 here is referred to as the first term. That is the first term. So in any sequence you have been provided with, the first number which will occur is referred to as the first term. And every number in that sequence is known as a term. Every number is a term. In that, here 4 is a term, 6 is a term, 8 is a term, 10 is a term as you move on. But this one is the first term. This one will be the second term, third term, fourth, fifth, sixth term as you move on. So that is how we find them, and they are given on. So we shall see an example. Given the nth term of a sequence is given by, now we have been given a certain formula for getting a sequence here. That formula we have been given that given the nth term, we have been told nth term of which we don't know at which number will it be. So given that one is equal to, that sequence is 2n plus 3. Given the nth term of a sequence is given by 2n plus 3. Find the 30th and 20th term. So if this one we have been given that, then we should find the 20th and 30th. To find the 20th and 30th, we shall use this one here, and you know, if 2n plus 3 we have been given is a sequence, then it means that for the case if we want first term, then first term will be allocated from this when n equals to 1. If n is equal to 1, that one will be our equivalent to first term, meaning that to get the first term here, you will have to take 2, you multiply by n, which is 1 now, then you add to 3. If you do that, you are going to get the first term will be 5. But we have been asked to find the 20th term. If it is the 20th term, we know now n represents the number which we are seeking. For example, the nth term will be sought by replacing n by nth, and then we add 3. So, meaning if it is 20th term, then it will be the formula of how it is, you multiply by the term which you are seeking at that point, and here we are seeking at the 20th term, so we shall multiply by 20, then we add to 3, and we find that number at the 20th term will be equal to 40 plus 3, and you will find it 43. And if it is the 30th term, then the number at the 30th term will be 2n plus 3, and it will be equal to 2 multiplied by 30. Then you add 3, and you will find out that you are going to have 63. That number will be 63. So if you want to get any number given, so long as you have the formula, you only substitute the required condition into the problem, and then you find out whatever you are seeking for. So we have seen how you can find that, and let's see another one here. Find the general rule in the sequence given as 2, 5, 8, 11. We have 2, 5, 8, 11. We need to find a general rule here. As we can see, you will find to move from here to here, there is an additional of 3. Here to here, there is also an additional of 3. From 8 to 11, we have an additional of 3. And it will continue with an additional of 3. But we know one thing. To obtain the numbers given here, we have to formulate a formula which will help us to get that number. And that formula we may find is that, let's take for example, we have the first term. We need the first term. So we take that first term to be equivalent to that n which we are seeking, but we say it is n. How can we write that formula in that process? You will find out that to get these 2, if we have n equal to 1, then 2 can be obtained from 3 by taking 3, you multiply by 1, then you subtract 1. If you want 2 in terms of n, where n is equal to 1, then you have to take, if there is an additional of 3 here, to find this one, you will have to take 3 multiplied by 1 to get 3, and then you subtract 1, you will find it is 2. If you want the second term which is equal to 2, second term, actually the second term is equal to 2, then to get this second term here, you will have to take 3 multiplied by that 2, then you subtract 1, and you will get the second term is 5. That is 6 minus 1, you will get 5. So meaning that the formula for obtaining this one, we shall find out that if you add here, you will find this one is 14. As you move on, 14 plus 3, you will get 17 as you move. But if you use a formula you have found, it is 3 multiplied by this n here, 2, 1 was representing nth term. So we shall multiply by n. That means the number at the position which you want to seek, and then you subtract 1 and you will find your term. For example, if it's the term, the 6th term, then we shall replace n by 6, and then you will find your answer will be that what we have found, 17. Meaning that it will be 3 multiplied by 6 and minus 1, you will find this answer will give you 17. That suggests that the general formula for the equation here, or for the sequence here, is given by 3n minus 1. That is what we shall find out as the general formula. Let's see how we can find geometric or arithmetic sequences. If we have one, and say we shall start with the arithmetic sequence. We shall observe a given pattern of number and see how does it behave. For example, having 1, 4, 7, and 10, we need to observe this number. How does it appear or behaves? We shall see, in order to predict the next number, we shall study the behavior of the pattern and see what does it come out in order to have another number. You will find that from the first number to the second one, the second term, you are going to add 3. The same applies to the other. You are adding 3, and throughout the equation means you will be adding 3 to every preceding number in order to get a successive number. So you will be adding 3. If you want to get the next term, you have to add 3. So meaning here we are going to have 13. Here will be, if you add 13 plus 3, you are going to get here 16. Here it will give you 19 as you move on. So we are finding that we are going to get some numbers like that, but it is with addition of 3. So what we shall do here, we have learned that if you find this number here, we call this one the first term, and every number in the pattern is known as a term. So it will depend. If it is located at the second position, then it's called the second term. Third position is the third term. That way as you move on. Now here we shall introduce another thing from the behavior. We have found in order to predict the next number, we have to add 3 to the preceding number. That addition of 3, here this 3, addition of this 3 is what we refer to as common difference. And in most cases, we do abbreviate it with letter D. So, addition of 3 is known as common difference. And the first term here, which we have here, is written as, now that one here will be written as A. It's represented by letter A. If you see A in an arithmetic sequence or in any kind of a sequence, in most cases, A represents the first term. So meaning that if this was to be written in terms of A and D, then we could have a generality of, in general we could have, the first term could be A, because we have said that's the first term. Then the second term here could be A plus a common difference, because we had to add 3 in order to get 4. So a common difference, we have said it be D. The second one will be now addition of another common difference. So meaning it will be A plus D plus D. This is the second term, but we are adding another D in order to get the second, actually to get the third term here. So instead of writing that, we can just write 2D. Then as you move on, you will find you are having A plus 3D. As you move that way, you will find it moves that way. So if you want to find any of the term given, then you have to substitute there whatever you want. If it is a term like 7, then you will have to find 7 by taking 7, you subtract 1, you will find there whatever you want. So we shall find that formula. But for this one, we have found the general formula for obtaining here is like taking that one, A plus common difference, where common difference is 3. So that is what we have found, and we can use it to find others. Now let's see an example. For example, if we have a number like 5, 7, 9, 11, as you move on, let's find the next number and also find the general arithmetic sequence formula from the number given. Let this help us to formulate the general arithmetic sequence. So we have learned from what we have seen earlier that if we want to find the next arithmetic sequence pattern in term, is like following this what we have here as our formula. So you will follow that pattern in order to find the next term. So the first term here we have been issued with 5. So meaning A here is equal to 5. So our first term here is 5. Second term, which we said is A plus D, will be equal to 7. So meaning if you need the first term, you need the common difference, this D, you will have to take the second term minus the first term, meaning that it will be A plus D, you subtract A, and this one will give you D. So meaning if you take 7 minus 5, you are going to get our D to be equal to 2. So the common difference within the number or the pattern of that arithmetic sequence is equal to 2. So we shall be replacing from there what we have there, D 2 and A 5. So we are going to find the next number here, which will be the 5th, maybe with the 6th number. So we want to find the 5th. And here 1, 2, 3, 4. So getting the 5th, we found it will be A plus 4D. From what we have there, as we move on, it will be A plus 5D as you move on. So as you may observe keenly, you will find out that the first term here This is the first, this is the second term, this is the third, this is the fourth, this is fifth, and this one is the sixth. So we can observe out clearly and find that we can find another term there. For example, if we need the fifth, we just we substitute here a 5, and then here 4 multiplied by d, which is d is 2. So you will find this is giving you 8. 8 add to 5, you're going to get 13. So meaning here the fifth term is 13. And if you need the sixth term, you will substitute here a by 5, and then you add to this one 5 multiplied by 2, and you get, it will be 15. Now we have found, you will continue with the same process in order to get the next number in the pattern. But here, we want to generate a formula which will help you with ease instead of writing whatever we just wrote here. So you will find out that the first term is equal to a. Second term here is equal to a, that first term, plus a second term, subtract 1, then you multiply by the common difference. That is what we are observing. The third term there, this is the second term. So the third term will be a, which is now the first term. You add 3, which is the third, which we are finding. You subtract 1, then you multiply by common difference. So if you do that, you are going to get the third term. And the fourth term continues that way. We can see it is a plus 4 minus 1 multiplied by d. As you can observe, we are going to get, if the nth term is what we shall find, then it means we are going to replace these numbers here which we are finding, the terms, numbers, the position of the numbers by that n. So in case we want to find the nth term, in case it's the nth term, then it will be equal to a plus, now where 2 is, or the position of that number, we shall replace it by our position which we need to seek. Then we subtract 1 and we multiply by a common difference. This is what we do refer to as arithmetic sequence formula. So in case you want to find any term in arithmetic sequence pattern, then that term will be guided by this formula. For our case here, if we could just want to find the fifth term, you will find here to find the fifth term will be equal to a, which is 5, then plus n. N here we want the fifth, so it will be 5 minus 1 multiply the common difference we got. The common difference was 2. So if you do that, you are going to get, it will be 5 plus, this one is going to give you 8, and that is 13. That's the easiest way of finding next term in arithmetic sequence. Now we have seen the formula, and the next we are going to see an example on it to guide us much more on what to find. Now let's see an example where we are told the 20th term of an arithmetic sequence is 60 and 16th term is 20. Find the first term and the common difference. Now we have been told the 20th term. From arithmetic sequence we found that if we want to find the nth term, then it is equal to a plus n minus 1 multiplied by d. And here we have been told the 20th term is equal to, we have been told is 60. So if it is 60, it means we have a certain number. In case that number you take, which is the first term, you add now to 20 minus 1, you multiply by a common difference, you will find 60. And then we have another term which we have been given 16th term, and this 16th term we have been told is equal to 20. And that one also can be obtained by taking a plus 16 minus 1, then you multiply by d. That is how we do find those numbers. So meaning that the two numbers can be found, a and d can also be found. So if that is the case, then we have to arrive at a conclusion that these are two simultaneous equations, whereby it will be a plus, now 20 minus 1 we are going to get d, so it is a plus 19d is equal to 60, and this one will have 16 minus 1 we are going to get 15, so it is a plus 15d is equal to 20. If the two, you see them clearly, you will find they are actually simultaneous equation. There are two linear simultaneous equations. We can solve them and find the values of A and the values of D. And here to obtain those values, we shall now subtract the two equations and to eliminate one of the unknown in order to find the other unknown. And here if we do that, we are going to get that. If you do that, you are going here to find 60 minus 20 you will get is 40. 19d subtract 15d, you are going to get, you will have 4d. And if you take a subtract a, you will get 0. So meaning you will have 4d is equal to 40. So meaning that 4d is equal to 40, and d alone you will have to divide both sides by 4. Divide this side by 4 and find d is equal to 10. You will get d as 10. Now after getting d as 10, you can still find a by substituting d in any of the equation. Let's take the first equation, which is a plus 19d equals to 60. If that is the case, then it means that if I take a, I add to 19 multiplied by 10, I should get 60. That gives me that a plus 190 I'm getting is 60. So let's see. What number if you add to 190 you will get 60. So that one is going to give us, you will find that you are going to have a equal to 60 minus 190, because you are going to subtract 190 from both sides in order to get a. So if that is the case, you will have no choice than to have a as negative 130. So we are finding that the first term of that, the first term is equal to negative 130, but the 20th term is 60 and the 16th term is 20. Common difference being 10, and that we can find another one. So we were told find the first term and the common difference. So the first term is equal to negative 130, and the common difference we found is 10. So we have solved our question, and with that we can say we can use that formula of arithmetic sequence to find any given number with a given pattern of numbers. So we have finally find out how to find arithmetic sequence, and also using the formula of finding the next or nth term of arithmetic sequence pattern. You will find out any term in that sequence using this formula. In case you are subjected to any of the patterns or numbers which are given with a specific rule, then just find the common difference between the numbers if it is an arithmetic sequence, and then you use the formula to find the nth number you want to find in that pattern. With that, we have come to the end of arithmetic sequence. Let's see how we can find geometric sequence. Let's now see how we can find geometric sequence and how a number or given pattern of numbers lie under geometric sequence. From what we have observed from arithmetic sequence, we have seen how we can find a sequence and say that sequence lies under arithmetic sequence, and also we have formulated a general formula which can be used to find the next pattern in the next term in a pattern of arithmetic sequence. Now let's see what patterns of number lies under geometric sequence, and also we want to formulate a formula which will help us to find the next term in a geometric sequence. So we shall start first with considering a given number such as a given pattern of numbers such as 1, 2, 4, 8, 16, and so on. From this pattern of number, you will realize that if we take the second number or the second term, we say this which we belong here, all the numbers in a sequence are known as terms. So if you take the second term, you divide by the first term, you are going to get the answer is 2. The same applies if you take the third term, you divide by the second term, you are going to get your answer is 2. The same applies to the fourth term, and that gives us 2. The same to the 16th term, that is 16 over 8, you get 2. So that one continues as you move on to the pattern. So meaning, if you need to find the next term here, for example, if I want to find 4, then I need to take this 2 which is now constant here. We are finding this one here are constants. 2 is constant. So meaning that if you take 2 over 1, you are getting constant, which is equivalent to 8 over 4, which is equivalent to 16 over 8. We are getting that one is what we are finding there, and that is what we call a constant. Now, if you need to find the next term in that pattern, you will have to take, if you want the next pattern, for example, you will have to take that number. If we have, for example, let's say is x. Now over 16, you multiply, you will find that one is equal to k. So if that is the case, and k is 2, then it means x is equal to 16 by 2. So we have found, if you want to find the next number here, you will take that, the preceding number, you multiply by our common factor there, which is 2, which is constant. So if you take 16 multiplied by 2, you are going to get here is 32. Here by 2, you will get 64. As you move on, as you go on, 128 and so on. So we have realized that in that pattern of number, if you take the next number you divide by the preceding number, you are going to get a constant throughout. So such a constant which when divided, for example, after dividing like that, we find that constant are 2. Here 2 is what we do refer to as common ratio. The constant found by taking a next number in a pattern, dividing it by the previous, and you find it is constant throughout the pattern, that constant is referred to as common ratio. And any sequence that will appear to have a common ratio throughout, whereby in case to find the preceding number, you have to multiply the initial or if you want to find the successive number, you have to multiply the preceding number by 2, then or by that common ratio. That sequence is known as geometric sequence. So meaning that a geometric sequence is a sequence in which it contains, or you will find, common ratio. It is associated with common ratio, and we have seen. So meaning what? We can observe from this that if we call that a common ratio, we can give it or assign it a letter R. Let this one be equal to R, or a common ratio may be just abbreviated as, from this one we abbreviate it as R. If we abbreviate as R, we may say that is R. So we shall realize that if you want to find the next term from this, you will find out that in the previous here, this one is referred to as the first term, and it is written as A in terms of letters, for example. So we shall find, if this is the first term, we can substitute it by letter A. And this one now, to find this one, because we have said to find the next term, you have to multiply the preceding one by a common ratio. And our common ratio here was 2. So let's take that common ratio as R. You will find this one will be equivalent to AR, whereby A is the first term R is the common ratio, and if you multiply 1 by 2, you are going to get 2. We have said A is 1 and R is equal to 2. So you will find out that for that third term is the same as taking A, R, but R now we are going to multiply it by R, then we multiply by another R. So meaning it is going to give us AR squared. You will find AR squared because you will multiply by another R. Or if you want to do it in another way, you will find out that you can also obtain the third term by taking AR, because it's the third term, you raise it to 3, then you subtract 1. You will find your answer as AR squared. Or if you don't want to do that, you can take the second term which we found, or the first term. The formula says if you want to find the next term, you take the preceding term, you multiply by common ratio. So meaning the first term here is AR, so you will find it's AR. Then we multiply by another common ratio you are going to get is AR squared. The same with what we have done up. Here the meaning is that if you need the third term, you take AR but you raise to that term which you want, then you subtract 1, you will get is AR. So that gives us an indication that the terms above can also be represented as AR squared, AR cubed for the fourth term, AR for the fifth term, and also AR fifth for the sixth term. So that is what we have identified from that pattern of number. And we have said a pattern of number or sequence which have a common ratio is referred to as geometric sequence. And we have seen in order to predict the next pattern, you will be taking A, which is the first term, you multiply by R, and that R will be that the preceding number will be multiplied by R. So you will find as you move on, the R will be increasing in power as we have seen. So with that we can say this is the general formula for finding the pattern which we see here. So we can say this. Suppose A is our first term. Suppose A is our first term and R common ratio. And the numbers of pattern which we want to find is N. Position which we want. Position of the term. We want to find the position of that term or the term at the position N. For example, not the fifth, we want at N. So, meaning that is equal to the nth term. How will we obtain that? You will find out that from the formula, you will have to go, if it's 5, if it's the fifth, we said you take 5, you subtract 1, you will get 4. And now, if it's N in place of that 5, you will find that it will be your formula will be A, R, raised to that N, which is the position which you want to seek, then you subtract 1. If you do that, you will be finding the nth term of that geometric sequence. That is the formula for finding the nth term of that geometric sequence. So that one will give you a nth term of geometric sequence. And with that we shall say, we have come to the conclusion that even if given a geometric sequence, we can use that formula which we have there to predict the next number or the next term in that pattern of the sequence. So we shall see an example and see how that works. we have the fourth term. The fourth term of a geometric sequence is 16. If A equals to 2, find common ratio. So here we have been told we have to find the common ratio and then the seventh term. The fourth term of a geometric sequence, fourth term, is equal to 16. If A is equal to 2, find common ratio. So we needed to find R. That is our common ratio. In order to find R here, you will use the formula here, whereby the nth is our 4 here. We need to find 4. So we need to find that fourth term. And you will say the fourth term will be given by taking A, whereby A we have been issued with and we have been told is 2. And then R, we don't know what is our R. So R is not present. So here where we have 4, or the fourth or the nth term, we have found that if we find that nth term, we shall find is 16. But R, we don't have. And N, we have been issued with the N, we have been told N is equal to 4. So we shall take 4 minus 1. So as to find that. So you will find out that 16 is equal to 2, and this will be cubed. You're going to have 2r cubed, because 4 minus 1 you are getting 3. After getting this, then if you want to get the value of r, you need to divide both sides by 2, and you will get that your r is going to be, r is equal to, r cubed will be equal to 8. So you're going to get r cubed is equal to 8. If you want r alone, you have to find the cube root on both sides. You will only get r when you find the cube root on both sides. And finding the cube root on both sides, you are going to have this cube root will cancel r, cube of r, so you are going to have r is equal to, the cube root of 8 you will find is 2. So r is equal to 2. We have found that r is equal to 2 and a we were given as 2. So we can say the seventh term can be also found because we have a and we have r. So from the formula of geometric sequence, we have found that the formula says nth term is equal to a r n minus 1. So you will find out that if this is what we want for the seventh term, let's seek for the seventh term, what shall we find? A is equal to 2, that is our first term, which we were issued with. R we have calculated and found that R is 2, so we shall multiply by 2. But that R, we shall raise to n, whereby n is equal to 7, so n is the nth. So we shall find the nth term there, we are finding the seventh term. So we subtract 1, and you find that we are going to have 2 multiplied by 2 raised to 6. And you will find out that the seventh term is going to be 128. Actually, this one will give you 64, 2 by 64, and you are going to get 128. So the seventh term is 128. And now we have used that formula to calculate the nth term, whereby we have calculated it using that formula. We have found the common ratio, and also you can use the formula to find the first term if given a problem which requires you to find the first term. We shall see another one, and this one now I will give you to test and see if you find the answer. The ratio of the 10th to the 8th term of a geometric sequence is 9. So you are being told that the ratio of the 10th to the 8th. So meaning if you take the 10th to the 8th, you have been told that the ratio of that one is equal to 9. Find two possible common ratios. Actually, let me help this. If you have that one, you will know that from the formula, we said that nth term is given by n minus 1. But you are being told that the 10th term, if you take the 10th term, its ratio to the 8th term, you are going to get is 9. So what we are going to do here, you will just take a, then r, but here we have told is 10. So 10 subtract 1, and here you will have AR, but here is 8 minus 1. You're going to get, this one is going to give you, this one will give you AR raised to 7, and this one is going to give you AR raised to 9. You will find that one, and after getting that, you will find that you have been told if you take the ratio of the two, that is the 8, the 10th to the ratio of a, you are going to find that you will find the answer is 9. So meaning that if you take the 10th term and that is AR raised to 9, so we are going to have AR raised to 9 over the 8th term, and 8th term here is AR raised to 7, is going to give you 9. And from the look of things, you are going to find that A will cancel with A. And here, if you have two common factors, we remember from logarithm, you will find that if you take AM divided by AN, we did say that this is the same as taking AM minus N. I think you remember that. So meaning that for this case here, you will say that R raised to 9 divided by R raised to 7 is the same as we are going to get R 9 minus 7. And that one is going to give us nothing but R equals to R2, because 9 minus 7 you are going to get 2. So R squared is equal to that 9. So meaning if we were told to find two possible ratios of R, then it means that R can only be obtained by finding the square root on both sides, and we shall find the square root of also 9. So you will find out that R is equal to, because the square root and square will cancel, and then you will find the square root of 9 will give you two possible values, that is positive 3 and negative 3. It may be either positive 3 or negative 3. In that, if you want to find R, it may be either the positive square root of 9 or negative of 9. So you will have R as either 3 or R as negative 3. Those are the possible answers or the possible values of common ratio. So I have helped you. You will seek some of the problems which involve geometrical sequence in your mathematical book, which is approved by KICD, and seek out some of the terms or the sequences of geometrical sequence which involves with the same problems. Then try to handle them using the same technique as I have given you, remembering that the formula for getting the nth term in a geometric sequence is given by AR raised to n minus 1. Let's now look at series. Under series, we shall find out that series here refers to the sum of all the terms in a sequence, may it be arithmetic or geometric sequence. If you add up the two, if you add up the terms in that sequence, then that is what we refer to as series. If it is an arithmetic sequence and you add up all the terms, then we refer to that as arithmetic series. So we shall start with that, and we shall say we are going to start with arithmetic, or it's called arithmetic series, or sometimes it's called arithmetic progression, or it has another, it's arithmetic series or arithmetic progression. And this one, sometimes you may find it is abbreviated as AP. So if you find somewhere you have been told, find the series of AP, find the sum of AP, and you have been given that one, they are referring to arithmetic progression. And remember from what we did previously, we saw that if you want to find the arithmetic sequence, we did say the formula for finding the nth term was given as A plus n minus 1, then D. I remember that is what we gave out. So if you have terms, for example, like, let's say we have terms like 2, 5, 8, 11, and so on. So if we needed to find the next numbers, we did say you will find them from the formula A plus n minus 1 D. And that, if that is the case, then you substitute A where A is 2 and D will be 5 minus 3 or 8 minus 5 or 11 minus 8. And you will find D equals to 3 and N will be depending the position which you want to see. So if it's here, for example, we can predict some more numbers of that pattern, and we shall find this one is going to give us 14, 17, 20, or you move on, you will find 23, and so on as you move on. Now, I have formulated much more of the numbers from 11 using the formula of finding arithmetic series, and we have found you will find some more numbers up to that. So we have seen that if you want to find arithmetic series, I mean this is arithmetic sequence. So if you want to find arithmetic series, then it means we are going to find the sum of arithmetic sequence. And if that is the case, you may be told to find like the sum of arithmetic series, and arithmetic series mostly is abbreviated, or in finding, we find the sum as S. So you will find it is written as S. So that if you have been told to find the series, the sum of the arithmetic sequence, for example, S2, then that means you are going to sum 2 of the arithmetic sequence terms. So if that is the case, this one we are going to sum 2 first arithmetic sequence term, and we are going to find it will be equal to 7. S represents the sum of those 2 sequence term. So it is 7. And if it is S3, you will find out that it is equal to 2 plus 5 plus 8, and this one will come out as 15. You will find out that as you move on, it is going to be much more interesting, and in that we are going to have different kind of them, so that in case you want to find S4, you will find S4 is equal to 2 plus 5 plus 8 plus 11, and this one is going to give you a certain answer such that you will get is 26. So we can go on and find S6. S6 you will find out is 2 plus 5 plus, actually let me write up so that it may help us much more. S6 you will find this is for 1, 2, 3, 4, 5, 6. So we shall end at 17. And you will find S6 will be 2 plus 5 plus 8 plus 11 plus 14, then plus 17. That's the end of S6. So if you have been told to find that sum, you will find the sum is equal to, you're going to find the sum as 57. The sum can be found in that process, or you can revise it and say that you can find S6 also by taking from the largest term in the sequence. So it will be, this is what I'm referring to series, this is what I'm referring to series. So if you sum up an arithmetic sequence, then you will have arithmetic series. This is an arithmetic series. It may be up to given position. It goes on up to given position. But me, I'm ending at arithmetic series at point where it is 6. So this is the 6th term in arithmetic sequence. So I'm summing up and coming up with a series. In short, what I mean that if you sum up or some of the given arithmetic sequence terms, you will end up having a summation like this, all the terms being together by addition sign or subtraction. But in most cases, it's addition. Summing is adding. So if you add, you will come up with that. This is what we are referring to as series. And since we are summing up arithmetic sequence terms, then this series will refer to as arithmetic series or arithmetic progression. So if we sum up, we shall find that if we sum, for example, up to 6, we are going to get 57. That's the reason why I say, in case you start from the largest series you have, from the largest term to the smallest, you will find that you will have a series of the similar but starting from the largest to smallest, and it will be, in this case, plus 2. So having that, still if you sum up, you will end up by having 57. And we can notice that from the 2, you can still notice that if you take S6, which is this one, S6 series, that is 2 plus 5 plus 8 plus 11 plus 14 plus 17, you add to another S6 in another way, from largest to smallest, plus, let's say, plus S6, which is 17 plus 14 plus 11 plus 8 plus 5 plus 2. You are going to get 2S6. You will end up with the 2S of 6, and that S of 6 is sums of S6, and this one is going to give us, if you sum this one, you add to this one, you are going to get 114. Actually, it's giving you 114. Here, if you sum, it's 114. So we are getting the answer is 114. But we need only S6. So if that is the case, you are going to get S6 is equal to 114 divided by 2. If that is the case, you are going to end up with 57. So we have seen how that one can be brought about. And we are seeing that one is equal to 57. We can use the same procedure which we have used here to find where the terms of arithmetic sequence are represented by numbers. That is in terms of first term, n, and common difference. And find out the arithmetic series, corresponding arithmetic series, and then we sum and see what can we get as the formula for finding the sum of arithmetic series. In case we have an arithmetic series of arithmetic sequence of a plus b, a plus 2d, up to a plus n minus 1d, you will find that if we form an arithmetic series, then it will be s of n. We need to find the sum of all these up to this nth term, and you will find s of n is equal to a plus, we want that series, so it will be a plus d, this is the second term, plus a plus 2d, the third term, up to plus, so you will add up to a plus n minus 1, then b. The same can apply in that if you are summing also, we add to another sum in that we are starting from the highest or the largest term in that series and then to smallest. So we shall start with the a plus n minus 1 d, as we were doing for that of S6, remember? So if that is the case, then we shall add up to where we have a plus 2d, and we are still going on to add a plus d up to plus the lowest term in that series. So you will find that you are going to have 2Sn, that is 2Sn is equal to, if you sum up this first term, corresponding first term and the largest term as you go on, you will find this one is going to give us 2a, it will give us 2a plus n minus 1d. The system will continue, you will find as you go on summing up, you will find that you are going to have, the system continues that way until you will have 2a plus n minus 1d, that way as you go on until you find the last term, and that one also still is 2a plus n minus 1d. You can make that investigation by yourself and see. It still gives you that one. So you will find out that is what it gives you. So meaning, this one is similar throughout, this one is similar to this, to that. So we can factor out one of them, and we shall find if we have n number of that terms in this series, then we shall end up having, actually this one is one term, two terms added together that way as we move on. So you will find you are still going to add that way. So that if that is the case, we are going to have 2n is equal to, if we do on by factorizing this one, we shall find 2a plus n minus 1d is common throughout. So if we factor out throughout that one, we are going to have n times of them, and it will be n because we are seeking the nth term. So we shall have, here we're having 2Sn. So we shall have nth of them. Then this n, if we sum up, we shall just take 2a plus n minus 1d. This one is found by summing up all the terms which we have found there in that series. So you will find out having that. And if that is the case, we can still find one of s. We can find s, whereby s, 2Sn is equal to n into 2a plus n minus 1d. So if we want n, we are going to divide by 2 on both sides. So if we divide by 2, we are going to find if also this side is divided by 2, you will find that we are having Sn as, if we divide it by 2, we are just taking n over 2. That is what we shall have because it is multiplying throughout the bracket. So n over 2 is equal to 2a plus n minus 1d. And this is what we refer to as the formula for finding arithmetic series. So if you want to find the nth term, may it be 4, may it be 6, may it be 7, what you only require is this formula and the number or the first term and also the common difference. And if you have been denied with the common difference and you have the first term and also the nth sum of that one, if you have been given, then you can find the common difference by using still the formula. Let's see an example, one example, and see how we can use the formula to make working efficient. The sum of the first 8 terms of arithmetic progression, AP, is 220. If the third term is 17, find the sum of the first 6 terms. The sum of the first 8 terms of an arithmetic progression, AP, is 220. So we have been told that S8 is 220. And we have been asked that is 220. If the third term is 17, third term, now we are being issued with the third term. Find the sum of the first 6 terms. So you need the sum of the first 6 terms. Now what we shall do here, you have been told that the third term is equal to 17. and the sum of the 8 terms in that arithmetic progression is 220. So we need to find the sum of the first 6 terms in that arithmetic series. So what you need here is only simple. Remember the two formulas connecting the two subtopics. That is the formula for finding arithmetic sequence and also the formula for arithmetic series. So what we shall have here is that we know if this one is the third term, to find the third term we know is third term you will find it as taking, actually remember the formula says to find the nth term is given by a plus n minus 1 and then b. But here we have been given 17 is equal to a plus, now here we have 3 minus 1 multiplied by the common difference. So if the sum of the 8 first term is that's 220, if the third term is 17, then we find it. So that is what we are going to have. So the first term we don't have, we need to seek the first term, and the common difference also we don't have. So if we do that, we are going to have 17 is equal to a plus 2d. So we are going to have that one as 17 is equal to a plus 2d. We have found that. Then let's see what happens next. We have found, using the third term, that third term, which is 17, is equal to a plus 2d. Now let's see. What shall we find in the sum of 8 terms of arithmetic series? So we shall find out that we said to find the sum of arithmetic series, we have a formula of n over 2 into 2a plus n minus 1b. So if that is the case, we have been told this one is 224 S8, and if that is the case, then means 8 is our n. If we divide by 2, then we multiply by 2 plus 8 minus 1. We are substituting, multiply by d. This one will direct us to find a and b. So this one here, if you do the division, you are going to get 4. And here you will remain within two brackets 2a. And here 8 minus 1, you are going to get 7. So you have it plus 7d. And this one is in the bracket. So if you open the bracket, you're going to have 8a plus 28d is equal to 220. Actually, as you can see, we have formed two sweet linear simultaneous equation. That is 220 is equal to 8a plus 28d, and the first one we formed was 17 equals to a plus 2d. So we shall solve them simultaneously and find the values of a and values of d, so as to enable us to find S6. So we shall find that if we take a plus 2d, we shall find 17. And if we take 8a plus 28d is equal to 220. I want to solve this equation by simultaneous equation of elimination method. So what I will do, I want to eliminate a. If I want to eliminate a, then it means the first equation here I have to multiply by a, such that to make that the size of a to be similar, so as I eliminate by subtraction. And if I do that, I'm going to have 8a plus 16d is equal to 17 by 8. I'll guess is 136. So I find that one as 136. And this one remains 8a plus 28d is equal to 220. If that is the case, then after reaching that point, I will now do the necessary by subtracting or minusing the two equations, and I will find out that if I take this 136 minus 220, I am going to get negative 84. and here 16 minus 18 will give me 16 minus 28, I'm going to get negative 12. So this one is going to give me negative 12d, and here I'll get 0. So 0 minus 12d equals to negative 84. If I need to find the value of d, I'm going to take that negative 12d equals to negative 84. So the value of d is only obtained if you divide both sides by negative 12. By negative 12, you will find that your d is equal to 7. So we have found that d equals to 7, and that means that the common difference is 7. So after finding d equals to 7, we can use one of them, of the equation, to help us find what is the value of a. I will suggest we use this equation here, or which is present here. And if that is the case, we are going to have that a plus 2d, and d, a plus 2d, but d here we having 7, so if we do that, we are going to get 17. If that is the case, we are going to find a plus 14 is equals to 17, and now we shall get our first term equals to 17 minus 14, because if you want to get a, you have to subtract 14 from both sides and get a equals to 17 minus 14, which is equal to 3. Now we have found the first term. We have a common difference, meaning we can find S6, where n equals to 6. So the sum of the first 6 terms in arithmetic series will be equal to S6, now will be equal to n over 2, but let us write the formula. So Sn is equal to n over 2, 2a plus n minus 1b, and that one will be giving you that formula of arithmetic series. So meaning if it is S6, we are going to have n, but n is 6 over 2. Then we have 2 multiplied by a we have found is 3. Then we shall add to n minus 1. N is 6, so 6 minus 1. Then d we have as 7. We shall find out this is 3. 2 by 3 is 6, so we shall have 6 plus. If you subtract 6, 1 from 6, you are going to get 5. 5 by 7, you are getting 35. So add the 2 will give you 41. And if you take 41, you multiply by 3, you are going to get 123. So meaning S6 equals to 123. S6 equals to 123. So that is how we do solve that equations. You may find any other problem, but remember, in solving arithmetic series or arithmetic sequence, you first have to have the knowledge of how to find arithmetic sequence. If it is arithmetic series or arithmetic progression, what you should do here, find out what is the formula for finding an arithmetic series. After finding that formula, then you will know how to use. In every case, you will find the problem containing arithmetic series. With that, we have come to an end of arithmetic progression or arithmetic series. We want to see more on arithmetic and geometric series or geometric progression. We have seen how to find an arithmetic series, and now we are going to see how we can find geometric series or geometric progression. Here, we do refer to those sums of geometric sequence. If you find any sum of the terms which are included in a geometric sequence, then you will be finding geometric series or geometric progression. We shall consider one of the sequence in geometry, that is a geometric sequence of and so on. It may be by and so on. So you will find that for a series like this, a sequence like this, we may generate a series from that sequence and a progression sequence. This one will be called a geometric sequence because if you take 6 over 2, you will find it's equal to 3, and this is what we are referring to common ratio because it's common throughout the sequence. So, meaning that if we sum up the terms which are located in a geometric sequence, we are going to have a geometric series. So, if we are required to find the sum of the first, let's say 2, the first 2 terms in a geometric sequence, then we are going to have 2 plus 6. If you have 2 plus 6, which where 2 plus 6 are terms in a geometric sequence, then what I'm resulting with here is what we do refer to as a geometric series, or sometimes it's called geometric progression, GP. So that is what we do refer to as. If you have the sum of some terms from geometric sequence, we are saying it's a geometric series. So this one is going to give you 8. The sum of the first 4 terms in a geometric series will give you 2 plus 6 plus 18 plus 54. And you will find out that that one is going to be, you are going to get is 80. The same can apply if you sum 6 terms from that, and if you sum 6 terms, you will find out that you are going to have 2 plus 6 plus 18 plus 54 plus 162. Then you add 486. You will find if you sum those terms from a geometric sequence, 6 of them, you will find they will give you a sum or a geometric series of 6 terms, and that is what we have. So if we are going to sum up, we are going to end up with the 728. So this is what we are going to get. But remember one thing, that is what we got. So meaning that S6 is equal to 728. Suppose we multiply by a common difference on both sides, such that this equation we may call it equation 1. So suppose we multiply both sides by common ratio, which is common ratio here we found is 3. So if we multiply by 3 on both sides, we are going to have 728 multiplied by 3, and here also S6 multiplied by 3. Is S6 with denominator 6, meaning subscript is 6. So meaning we are finding the sum of 6 terms. So if we multiply by 3, we are going to get, this one will give you as 3 of S6 is equal to 728 multiplied by 3, and you're going to get it 2184. So after having that, now let's take S6, or this one as equation 2. Then we do take equation 2, we subtract equation 1. We subtract equation 1 from equation 2. So if we do that, we are going to have 3S6, which is equal to 2184 minus S6, which is equal to 728. And if we take the like terms, we are going to find that we are going to have an equation which is similar to 3S6 minus S6 is equal to 2184 minus 728. So if you do that, you are going to get here, if you subtract, you are going to remain with the S6, which are 2, and here you will get 1456. So if you need to find S6, you will divide both sides by 2, divide by 2, and you will find that S6 is equal to that one divided by 2, you are going to get 728. So we have seen it just similar. What only changes is the method of finding it, and the way we have found it is what has mattered. So we first find S6 and we found out S6 was giving us that one. So if we do take S6 and we multiply by the common ratio, we shall find that the common ratio will give us 700, that is 2184. And we have found that it is 3S6. Then we subtract equation 1 from 2, whereby we are ending up with that, and we have found it's still the same answer. So we want to do the general way and see how we can find the general formula for finding geometric progression. Let's see how we can find the general method of finding geometric progression, and we shall say that in case you have been provided with terms like AR squared, AR cubed, up to AR raised to n minus 1, then that one we refer to as geometric sequence. If we want to generate a geometric series or a geometric progression from that, then it means if we want to find, we shall be finding Sn, whereby n is the number of terms which we want to find. Now it will be equal to A plus AR squared plus AR cubed up to, so we shall continue adding up to addition of AR n minus 1. So that is what we are finding. So that is the answer for finding that S of n. So that is nth terms. The sum of the nth terms we shall find in our geometric progression is equal to that. From what we have done in the previous example of finding S6, we shall multiply both sides. Let this one be called equation 1. This equation here be called equation 1. Then we multiply equation 1 by common ratio. We shall find that if we multiply throughout by common ratio, we shall find this one will become Rsn is equal to, this one multiplied by common ratio is Rn, this one by common ratio is AR squared, the other one turns to AR cubed, the other one AR raised to 4, and so on as you continue until this one. Now because we are multiplying by, look at this, you have AR n raised to 1, then you are multiplying by R raised to 1, only one R. So you will find that this one, because here we have the same, you will find it's just AR n minus 1 plus 1, and this one is going to give you AR raised to n. That's what you will end up with. So meaning that the n term will be AR raised to n. That is what we are going to have. So this one, call it equation 2. If that is the case of equation 2, then we are going to do another thing on this, so that we may do it this way. Let's subtract, as we did in the previous example, subtract this one, or this equation 2, then let's subtract equation 1 from equation 2. Or take equation 2, we subtract equation 1. We are going to get, if you do to subtract, Rsn is equal to Ra plus AR squared plus AR cubed plus AR raised to 4 up to AR a raised to n. We are subtracting Sn, which is equal to A plus AR squared plus AR cubed plus up to AR n minus 1. Then on subtraction, we shall find out that this one will be Rsn minus Sn is equal to, if you subtract, we shall only remain with this one here, and it will be negative. but this one here will be positive. Since this RA will be subtracting with AR, and we shall find they will all cancel out, and we will remain with Rn minus A, whereby A is for the denominator here, for the other S. So you will remain with this as the entire sum of that geometric sequence after multiplying by common ratio. So after doing that, from this we can factor out Sn and find out that you will have R minus 1, S1. Actually, factoring out Sn, you are going to have Sn into R minus 1 from this part here, and that one is equal to Rn minus A. So if you want Sn, divide both sides by R minus 1, divide both sides by R minus 1. So you are going to get that Sn is equal to Rn minus A over R minus 1. That's the formula of finding geometric series or geometric progression in case where you have been given R or the common ratio is equal or is greater than 1. If the common ratio is greater than 1, then you shall be using this formula here to find the geometric series or geometric progression of that given pattern. So let's see for the case where you subtract equation 2 from 1. If you do subtract equation 2 from 1, then you are going to end up with Sn is equal to, you'll have Sn is equal to, now we are taking equation 2 was A plus AR squared plus AR cubed plus up to plus ARn minus 1. So if we do subtract now Rsn, which is equal to AR plus AR squared plus AR cubed plus AR raised to 4, and then we add up to AR raised to n, we are going to end up with, you shall find, you will have Sn minus Rsn is equal to, now here we shall start with the A from the top, which will shall remain only, because this one are going to cancel themselves. These terms will cancel themselves, because if you subtract they will vanish, and we shall only remain with minus A R raised to n. And if that is the case, you will find out that this one is going to be that way, and if you factor out here Sn, we are going to get, now here we forgot one, whereby if you subtract, you shall remain with that. So here it should be AR, not R alone. So if that is the case, you will find it will be throughout AR. And here, factoring out A, you will remain with Sn equals to A into Rn minus 1 over R minus 1. So this formula here is what we refer to as where Sn is equal to A into Rn minus 1 over R minus 1 is the formula for finding geometric series or geometric progression when R is greater than 1. Let's see for what happens if we do take, now after getting this way, now we can see that Sn is common in both of these, so we shall factor out Sn, and you shall find it is 1 minus R, and here A is common between them, so you shall factor out A, and you will find that this is 1 minus R raised to n. So if we want Sn alone, we shall divide both sides by A, so meaning Sn alone will be 1 minus R. We divide both sides by 1 minus R, and you will find it is equivalent to 1 minus Rn here, divided by 1 minus R. So we are going to have Sn equal to A into R 1 minus R n over 1 minus R. So that's one we have found is another formula in case you subtract what you multiply by a common ratio R from what was the initial. So you find that you will have this kind of formula. We can realize that from the two, we are having two different kinds of formula, from two subtraction, from two addition. So we are having two different kinds of formula. As per arithmetic series, we found it just gave us the same, but for progression, we are having two different formulas, where Sn for the first formula is A into Rn minus 1 over over R minus 1. This one was when we subtract equation 1 from equation 2. So this one was for the first one. And here we have found another one whereby we have Sn equals to A into 1 minus Rn over R minus 1 minus R. This one is another equation, another formula for finding geometric series where R is less than 1, and here is where R is greater than 1. So if you find your common ratio is less than 1, meaning it may be a fraction or a decimal or be negative, so you shall be using this formula here. If it is negative, a fraction or a decimal, you will be using R less than 1, so you will be using this formula. But if it is greater than 1, from 1 onwards, then you will be using this formula. So let's see an example to help us to solve one of the progressions, geometric progression using the formula. And we have the sum of the first three terms of a GP is 26. So using the formula, we shall see how we find out. The sum of the first three terms of the GP means geometric progression, is 26. If the common ratio is 3, find the sum of the first 6 terms. Now the sum of the first 3 terms. So we have been given the number of terms, and that is, we have been told it is 26 for the third term, and we are finding that the sum of those one are given as A. Actually, let me write first how it is. So you will find out that we have said for Sn formula, if R is greater than 1, we shall have A into R raised to n minus 1, then this one will be over R minus 1. But we have been given this n here, we have been given as 3. So if it is 3, we shall replace what we have here as 26 is equal to A, which we don't have, and R we have been told, common ratio we have been given is 3. So common ratio is 3. And remember, n we have been given also is 3. So it will be 3 here. Then we subtract 1 over R minus 1. And R is 3 minus now 1. So if we do that, we shall be finding the first term. And that one will be equal to 3 cubed is 27. 27 subtract 1 will get 26. And 3 minus 1 is 2. So times A will get A, and this one will give you 26. So meaning that we are going to end up with 26 is equal to 26 over 2 will get 13. 13A. So meaning A alone is equal to 2. So A equals to 2. So we have found that the first term is 2, common ratio is 3. So find the sum of the first 6. So we need to find the sum of the first 6. We have used the formula to find the first term. So we need to find the sum of the first 6, whereby Sn is 6. So we are going to find what does that represent. And if that is the case, we shall use this formula where there is letters we represent it by the real values, whereby we have first term as 2, and R here we were given 3, but N we have been given is 6, so N will be 6 minus 1 over 3 minus 1, and we get this one is the same as 2 multiplied by 3 raised to 6. 3 raised to 6, you're going to get is 729 minus 1. 728. So you are going to multiply by 728. Then you divide by 2. And you shall get your answer as, you will get your answer. We say you take 2 times 728 over 2, and you will get your answer. This one will cancel with this, and so you will have S6, actually S6, or the sum of the first geometric sequence or series will be equal to 728 if common ratio is 3 and first term is 2. Now, I'll give you this question. You will handle this. The fourth term of a geometric sequence is 192. If the first term of the sequence is 3, find the common ratio, the number of terms that will give a sum of 255. I will just give you a hint and you will have work out. You have been told the fourth term of a geometric sequence, not series. If it's a geometric sequence, we say the formula for finding the nth term was equal to ARn minus 1. So you have been told the fourth term. So you shall replace here and say the fourth term will be given by AR. Then the fourth will be 4 minus 1, and you get this one will give you AR cubed. But you are being told that the term of that the fourth term of the geometric sequence is 192. So meaning that 192 is equal to AR cubed. That is what you have. And if the first term of the sequence is 3, now you are being provided with the A. So meaning 192 equals to A. By where A is, you put AR cubed. And you are being asked to find the common ratio. Yeah, now you can go on, find the common ratio. After finding the common ratio, now you will use the formula where common ratio you will find is greater than 1. So you will use the formula of Sn equals to A into Rn minus 1 over 1R minus 1. This formula here will guide you to find the sum of the geometric sequence, geometric series which has been required. And here we need a sum that will give you a total of 225. So you have to find the number of terms. What I'm requiring here is n. You will have to give out what is the value of n. If a equals to 3 and r equals to what you will find. With that, we have come to the end of geometric sequence or sequence and series.